Hello and welcome back for week number 3. Yep, we're going to be doing 2 lessons, and yes, you have 2 math Excels to help you. Please notice that on this assignment sheet, if you click on these, you can actually print out these notes and have all the data in front of you, which might help some of you for doing data entry. So, without further ado, let's get started on the next lesson. And here we go. I've got my calculator handy because it will definitely come in available to be useful today. Today we're going to be talking about standard deviation. Now, standard deviation is just a way of measuring how spread out your data is. And you're going to be able to identify the difference between a population and a sample, which is not complicated. You can define the standard deviation, and because this year being the year that, well, things are a little bit different, we're not going to even bother to do things by hand. We're going to be doing things via calculator. And the good news is I know some of you would love a worksheet, but we're just going to do a Math Excel today because I assigned a worksheet last week and very few of you did it. If you still want to turn that in to me, I still will take it for partial credit. Please feel free to complete that and just either use the Cam Scanner app or just email me a picture of it. All right, by the way, when you're looking at the notes, you'll see that it actually has the answers to said worksheet there. Well, anyway, back to work. Here we go. Populations versus samples. Now, the population is going to be all of the members of whatever group you're working with. And a sample is just going to be part of the population. For example, one class is a sample. The entire population would be all the people that are going to the school. When you're conducting a standard deviation, you have to know whether it's going to be a sample or a population because you're going to be doing different formulas. Now, for our purposes today, let's just briefly talk about how standard deviation is a measure of the variation or how spread out the data is in the data set. Your standard deviation specifically measures how far the numbers are in the data set deviate from the mean. So it's going to be how far from the mean your numbers tend to be, or how close to the average the data is going to be clustered. All right, and let's actually get to the formulas here. Now, I need to tell you that you really don't need to pay attention to a huge amount other than to keep in mind that if you've got a sigma, that's what you want for the entire population. If, however, you only have a sample, we're going to be talking about doing S. Now, the net result is that everything is the same for the calculation, except that you divide by the number of items when it's a population, but when it's a sample, you're going to divide by n-1. The other thing I want to point out to you right now is going to be something over on the side. Occasionally, you will have it show up on the standardized test. The variance. Now, honestly, standard deviation is something you can put into your calculator. Oh my goodness, Mr. Johnston, what's the difference between the variance and the standard deviation? Just square your standard deviation and you get the variance. It's just going to be that simple. Okay? All right, now let's get to work on actually doing one of these. So here I've got this lovely little problem. It says finding standard deviation on a calculator, and again, remembering it's the sigma for the population and the S for the sample. So what I'm going to do is I'm going to look at a data set here. This talks about how many decades we've done and called data from a hurricane. And it says in decade 1 there were 19 hurricanes. And I don't know, what up through 2000. And it tells you how many hurricanes there were per decade. What we're going to do is we're going to take time out and I'm going to have you guys enter these into your calculator. So again, for those of you needing to know where or how I get there, I go to Stat, and now I'm going to go to Edit. And I'm going to enter that information. So take a few seconds and carefully enter the information. Okay, and I took the time to enter my values, and now I've got it all there. So how do I go about doing my calculation that'll allow me to find x bar and s sub x? Well, first off, I'm going to go second, mode, which is quit. I go back into Stat. I hit the right arrow for calculate, and I get one variable stats here, which is 1. Again, with the 84 pluses, you're going to have to scroll through this. I think on 83s and lower 84s, it should just go straight here. Now, I'm going to focus on, first off, x bar is 17.6. Okay, so I'm going to say that's going to be 17.6 there. Very nice. My S of x value, on the other hand, that's going to be this one up here. Notice it's not the full population. It's not all hurricanes. It's just the ones over the last 15 decades. So we're now going to say that we've got 3.641 is my standard deviation. Now, what that standard deviation means, well, for your purposes, it's just talking about how, in general, they're pretty close, okay? 3 is a fairly close number. If, on the other hand, if it was 35, we'd say things are a little more spread out. Now, let's take a look at another one and do another problem. Okay, once again, I'm going to enter this data in, but I'm going to do it once for the day shift and once for the night shift, because in this problem, I'm being asked to look at comparing both S bar, my median, my range, and my S sub x. So I'm going to compare my day shift to my night shift and see, well, we're trying to do some sort of quality that's going to be 8 micrometers of thickness. Well, let's see what happens. And once again, I'll enter my data. My data is now entered, and you can see up here, I've got all 4 of those items and everything else is cleared out. So I'm ready to go stat, calculate, one variable statistics, and I want to do that for list 1. Got it? And calculate. Now, I have my X bar is 8.1, and I also have my other information there, so let's see where I find that. Well, hold on a second, there it is. My X bar is 8.1, so I'm just going to fill that in, 8.1. It says that my S value is 0.1826. I'll just go to an extra decimal place there. Next, I am looking for my median and my range. Does it have that in here? Let's take a look. Well, I've got my median, that's 8.1. So I can still just fill that in. And my range, well, I have to go back to stuff we learned last week. What is my range? My range is going to be my max minus my min, which is going to get me 0.4. Okay, got my information for the day shift. Let's enter my information for my night shift and see if I have any differences. Once again, I've entered 2, 4, 12, and 14 here. I'm going to quit, go into stat, calculate, one variable statistics again, and here we go. It says that this time for the night shift, my average is 8. My S sub x in this case is 5.888. My median, scroll down and I'd say, well, that's 8, okay? But my range is 12. Now, what does that mean from your perspective? Well, we're now going to have to interpret statistics, which is where we actually get some value. What conclusions can I make based off my findings? Well, they both have fairly close means and medians, and I'm now looking at the last part. We're looking at the range and the standard deviation. In both of these cases, the number is much, much larger for the range and the standard deviation. Now, if I'm looking for something where I've got to have some accuracy, and this said that I was looking to be 8 micrometers in thickness. Okay, well, as an average, they are 8 micrometers in thickness. But let me be honest, as somebody who would hire somebody, I want the day shift to do it for me because I know that they're going to be very, very consistent. Whereas the night shift, they may have an average value that's okay, but individual parts, not so much. Okay, let's take a look at one more here. We're going to this time find the mean, median, mode, range, and standard deviation for the waiting times in minutes of the customers at Jefferson Valley Bank and the Bank of Providence. So let's see what we can do. And notice what we're comparing here is your waiting lines. Have you got multiple or just a singleton one? So let's get the data entered. Okay, my data is all entered. And let's see what I can do about doing my calculation. Stat, calculate, one variable statistics. Okay, so we've got mean, median, mode, all that sort of thing. Well, let's get going on this. For one, my mean is 7.15. My median, let me scroll down here, is 7.2. My mode is my most common one, and clearly in this case, my most common answer is 7.7. And then my range. Okay, so I'm looking at 7.7 and 6.5. If I don't trust myself, I'm going to say that my range in this case is 1.2. And back to my S sub x, I'm going to go back up here, and it says that my S sub x is 0.4767. Okay, now we're going to do the same data analysis, except this time we're going to be comparing that to the Bank of Providence. So let's take a second and see what we can do about entering that stuff. And here we go again. Next, I've now got my data all entered and I'm ready to do my calculations. So I go second quit, stat, calculate, one variable stats, and it says, hey, look at those numbers. 7.15. Scroll down to find my median. My median is 7.2. I'm looking for a mode, so I need to compare what is my most popular one. Hey, look at that. 7.7 again. My mean, my median, and my mode are all identical in this case. So the only way I can differentiate these two is by the range and the standard deviation. So I'm going to look back up at my standard deviation, see what it says. 1.822. And my range is going to be 5.8. Wow. And now you can see that range and standard deviation often are related. They don't have to be, because we're looking more at clusters of data than we are looking at individual pieces, whereas we're looking at high minus low here. Which one appears to be more efficient? I'm going to be honest. You may end up waiting a little bit shorter sometimes in the multiple waiting lines, but you also have the potential of waiting a lot longer, and the variations are very extreme. So I'm going to say I think I'd rather take the chance and just go consistent and have the values that are going to be the same, as opposed to having widely different things. All right, ladies and gentlemen, that's it for the day. So please feel free to get to work on your Math Excel. Rewatch if you need to, take notes on anything, send me an email. I can be reached generally Tuesdays and Thursdays. I've reserved for Algebra 2 Trig, so feel free to get in touch with me if you need to. Have a good week, and talk to you next time.